Hi, thanks for watching my video. I thought I'd put this video on because I've looked at Heron's formula for computing the area of a triangle knowing only the three sides. Just to recap what Heron's formula is, you just get the three sides, you add them together and then divide by 2 to get this number, or this variable we'll call s. Then we put the s into the square root here, the square root of s times s minus a times s minus b times s minus c, and this will give us the area. So I wondered if there was an alternative way of doing this. I've seen some examples on YouTube, but they involve right angle triangles, which is trivial really. I wanted something that would be completely independent of any particular angle, just the three sides. Anyway, there's this formula here I came up with. Now I'd be interested to see if anyone out there on the internet has seen this formula before, and please send me a link, but I haven't been able to find it. And it's quite a simple formula really. It's the square root of 4 times a squared c squared minus a squared plus c squared minus b squared, all squared. It's a bit hard to see the little square symbol up there, and it's divided by 4. Now I'll show you the derivation of this. It's really quite straightforward. We have our triangle here, A, B and C, and we drop a perpendicular, h, and divide the base into x and c minus x. So now we can have two expressions for the h, or at least h squared, using Pythagoras, and the fact that the left triangle here is right angle, and the right angle, also the right triangle is a right angle. So now what we have is h squared equals a squared minus x squared. We'll call that equation 1. And also for the right triangle, we have h squared equals b squared minus c minus x squared. And we expand that out, so we get b squared minus c squared minus 2cx plus x squared, or h squared equals b squared minus c squared plus 2cx minus x squared. Now noting from equation 1 up here, h squared is equal to a squared minus x squared. So we can simply put that in. Here. So we have a squared minus x squared equals b squared minus c squared plus 2cx minus x squared. And of course the x squareds cancel out on both sides, leaving us with a squared minus b squared plus c squared equals 2cx. Okay, so from this we can then just say x equals a squared minus b squared plus c squared divided by 2c. We recall that the general area of a triangle is 1/2 times the base times the height. Our base in this case is c, and we have our perpendicular height. Now from above, we can now have an expression of h squared using again the formula 1 back here, this formula. So we have h squared equals a squared minus, and then our expression for x goes in here, and we square that to get our x squared. Then our area can be written using the formula here in terms of h and x. So we have a half c times the root of a squared minus b squared plus c squared, all squared, on 2c. And if we carry the c inside the square root, it becomes c squared. This makes it a lot easier to cancel things out. So we can have c squared, a squared, minus c squared times a squared minus b squared plus c squared. Then if we bring the 2c out, we get 4c squared. The c squareds cancel out, and we divide the whole thing by 2. So now, if we bring the 4 and turn that into a common denominator for this stuff inside the square root, we end up with 4ac squared minus a squared plus c squared minus b squared squared, all divided by 4. Then we can bring the 4 outside the square root. Instead of divided by 4, it's divided by multiplied by a half. And the result of the formula is the square root of 4a squared c squared minus a squared plus c squared minus b squared all divided by 4. And you can try this formula out yourself. It does work, but I haven't seen it anywhere on the internet. I hope somebody out there has seen it somewhere. Otherwise, use it. Tell me what you think. Thanks very much for watching.